All right, everybody, so this is the Simple ML for Sheets. So I've already installed it. So it sits down here under my extensions, and you can get this, this spreadsheet yourself from their website, which is simplemlforsheets.com. So I'm just going to copy that and paste it in my browser, as you can see. So they've got this huge tutorial, everything you need to know. You can learn all about it, but I'm just going to walk through their suggested examples. So it's got, I don't know, 5 or 6 case studies. We'll just do them all. So if you don't have this down here, you just go to add-ons and you go to get add-ons, and then you do a search for Simple ML for Sheets. And mine's installed. You just hit install, and then once you do that, it should show up under extensions for all of your spreadsheets. The key to using Simple ML for Sheets is that you really need some nice clean data. You need columns that have column titles, data that kind of is always the same type, right? If it's a number, it's always a number. If it's text, it's always text. And you need to make sure, for example, that at the very, very bottom, there's not like a total. So many of my colleagues, they always have like a total column that just screws things up. So you definitely want to have it be nice and clean, and I'm sure you guys are used to that kind of setup. So when you're on a tab that you want to do something, so here we've got some missing values, like somebody forgot to say if it was male or female, and a whole bunch of times they forgot to say what was the species. And so what it wants to build is, I think what it does is a random forest decision tree to do this one. So I'm going to go extensions, Simple ML for Sheets, hit start. It always says working down here. Again, this basically runs it locally on your own machine. And then if you ever save the model, it saves it in your Google Drive. So what we want to do here is predict some missing values. So I'm going to predict some missing values. And I think let's try the sex first. So we'll do sex and source columns. Use everything except sex. Yeah, that makes sense. My guess is it doesn't need the year. In fact, I'll just take the year out. Advanced options, gradient boosted trees, random forest decision trees. So we'll do the choice, and then they say gradient boosted tree option generally gives great results. The decision tree option does not give the best predicted results, but the model can be easily interpreted with the understand a model task. So let's actually do that. Let's do the decision tree, and let's predict. So it said, boy, there's a 100% chance that this one's female, and there's only a 70% chance this one's female. Any others? Yep. 96% chance this one's female. Yeah, so you can see what it's done here. So then we can go to amount of details, value and confidence. Let's do value and details instead, and let's hit predict. So it's adding a few more things. So it's showing you the percentage of both choices, which is pretty cool. And then there is a way I know to be able to really understand stuff. So I'm going to go back here, and I'm going to go to advanced tasks, and I'm going to say understand a model. Use the data in the current sheet to better explain the model. This sheet should not be the one used to train the model. We didn't, well, I'm not sure if we did or not. I guess I'll leave that unchecked to see what happens. So I'm going to hit the understand button. Summary. We're predicting the sex. Input features was all of this. Quality. Advanced evaluation report not available. Data set. Explains everything. Variable importance. Which variables seem to be the most important? Mass and bill of depth. It really looks like it only used 2 of them. Include, okay, so we'd have to hit that and then plot the model. So basically it says, is your body mass greater than 5225? If it is, then it's male. If it's not, well, we've got to check some things, right? So you're able to see the decision tree. And so if you've learned about decision trees, you'll know that this is kind of how they work, and the right questions to ask are the way to do it. So you're able to say, okay, nope, I'm less than 5225. Okay, then is my bill depth greater than 18.5? Yes, it is. Well, then is your body mass bigger than this? It is. Oh, male. 100% chance. Negative female, well, it's kind of hard to tell, right? And so it's able to make it the best predictions. Let's see what happens if I hit this button. So now we can come to the data set, variable importance, predictions. Ooh, look at all this. Island, doesn't seem to matter. Bill length, weird. Doesn't, what? Bill length millimeter. Prediction. I don't understand the difference between these two graphs. Bill length, bill length versus bill depth. Oh, interesting. The island distribution. So just all kinds of data that you can see to try to understand which variables matter more than others. So that's actually pretty cool. Okay, so I think now what I want to do is I'm just going to delete all of this. Delete columns. And I'm now going to do the species instead. So let's come back here. Let's predict missing values. Let's put the, we're choosing, please give us the species. I don't think year matters, but what the hell, I'll put the year back in. Advanced options, let's have it do the gradient boosted trees. And we'll see the details. So let's predict. It was saying that gradient boosted is better, but it's just harder to interpret. Aha, so it's got, you know, a 98% chance that this is a chin strap one. But some of these are not as great, right? So I'm trying to look for ones that doesn't have a 90. 90, 90, 90, here's 90, 90, 90, 90. Seems like it's pretty confident. Here's an 89, right? So it's only 89% sure that that's a chin strap. So yeah, so that's actually pretty cool. So now if I go back to understand the model, I want the species one. Let's see what if it looks any different. My guess is that the far right tab is not going to be as useful because that's what it was saying, is that it's hard to interpret. So if we plot the model, oh, no, we can still interpret that. But it says this model contains multiple trees, only apply to the first tree, which may not be representative. And so the way forests work is it does a whole bunch of trees and it compares them against each other and takes some averages. And so this is just one of the many trees that it's able to produce. Okay, that's pretty cool. So now it says spot abnormal values. And so what do we have here? Shucked weight, viscera weight. I don't know what shucked means, but anyways, maybe it's some seafood or something. So we're going to go to back here and we're going to say spot abnormal values. And oh, it's like, let's spot abnormal values in the rings. Let's do shucked weight. Shucked weight. So based on everything else, did somebody put a shucked weight in correctly? And so this one, for example, looks gigantic. So does this one. So let's see what happens. Advanced, so gradient boosted trees, random forest decision tree. Let's go. Taking a while. Produce two new, okay. So basically, they're saying there's no problems here. Bunch of zeros. Scroll fast through the whole thing. It's basically saying, oh, there's one. There's a 5% chance that this is not right, and that we think that more correct, it should have an extra 0. Oh, that's super interesting. Like somebody accidentally put the wrong one in. Huh. Okay, so now let's do, it said it defaulted to rings, so let's try rings and see if it finds more there. Spot abnormal values. I'm curious if it just deletes J and K. It looks like it made L and M now. Aha! So now it's, oh wow, there's a 38% chance that this ring number, which is 19, really probably should have only been 11. That's pretty cool. All right, so case 3, training data set. So what we want to do is we say we're pretty confident about this data, and then we're going to evaluate it against this data, I think. So let's see. I believe what we want to do is we want to train a model, and we want to train for species, and I'm going to call this my cool species model. Okay? And we want to train to be able to predict the species based on all the other information. Let's use everything. Advanced, we'll do gradient boosted trees, which it claims works better than the others, and I'm going to train. 7 features. 1, 2, 3, 4, 5, 6. Yep, using 7 features. Task completed. Close. Okay, so now we've got a model. Make predictions, evaluate a model. Understand a model. Let's understand a model. Use the data in the current sheet to better explain the model. The sheet should not be the one used to train the... Oh, well, okay, so let's not do that. Export a model, manage models. Okay, well, now let's go use it. So now we've got an evaluation data set. Oh. Weird. So maybe it'll make some new predictions about column H. So let's see what happens. Can we use that? Train a model, make evaluate a model, understand a model, manage model, export a model. Manage models, train a model, make predictions. Use my cool species, and let's predict. So it's coming over here and says, I predict this. So let's see where it got it wrong. Basically, it nailed it. That's pretty cool. So you can see, in this case, we knew the right answer, but we're able to see, yeah, boy, it basically nailed it. Let's see, is there anywhere where it disagrees with itself? Not really. That's pretty cool. So it says the percentage chance of it being this, percentage chance of that, and that. That's pretty cool. So now we can come back here and we can export a model. Use the sheet's data as example. Use the first 3 examples of the current sheet to demonstrate how to use the export model. I guess so. Export. So this is making something that'll go in Colab, and then I'll fire it up in Colab. So I'm going to copy all of this. Select all. Oops. Copy. So it uses the first 3 examples. I'm going to do copy that, and then I'm going to go to a new Colab notebook. I'm just going to pause while I get this ready. Okay, Colab fired up. I'm just going to hit paste, and I'm going to hit execute, except it takes forever to import my drive. Because my drive is so gigantically huge. Well, I'll watch the time. So I'm just going to hit pause, and right now it's 10:23, so I'm going to hit pause. Actually, I'll just comment. So basically, the model is saved on my drive. I'm going to say allow, I guess. Connect to Google Drive, allow. I'm going to connect to myself. Yeah, I guess so. Continue. So this is the one, again, that's going to take a while. But the point is, it actually saves the model in my Google Drive. It's already there. So Simple ML for Sheets already does that. So now I'm going to pause. Remember, 10:23 is when I started this. Okay, it looks like it is already finished. That wasn't too bad. It's only 10:25, so it only took 2 minutes, and almost all of that was loading my drive, I'm pretty sure. So it predicts the examples, and what it's predicting is so 0.9954. Let's see if that's what it was the first row. 0.9954. 0.99. Yep. So it's basically returning all 3 of these because it did the first 3. So you could now do all kinds of things. And so if you are used to the YDF. Wait, is it YDF? Is that what I want? Yeah, that's their super duper model. Then you can do all kinds of cool things. So model.predict. So if I just type model dot, it doesn't tell me what's available. What happens if I just ask for the model? So it's a YDF model, and if you know how to use YDF things, you could just go crazy with this. So it's awesome that it gives you exactly the code. But look, really, most of the time, it's just unzipping something. Once it's unzipped, it imports it and loads your model, and you're off and running. So that's pretty cool. All right, let's keep going. So forecast future values we did in class, but I'll do it again. You need to have some additional rows. You need to put in some additional rows. So let's actually try to go further. I'm just going to see if it can detect the pattern here. Yeah, let's try to go way further. All right, now who knows, maybe it'll break down going that far into the future. And so now I want to come here and I want to forecast future values. Use the date, column categories, none found, advanced options. I'll just leave it alone. Output, I don't know what decomposition means, but we'll see. Forecast. Whoa, that is so cool. So it gives you the trend line in orange, and then it gives you the, what do you call this, variables, the seasonality in green, which it looks like, these look identical to each other. Yeah, so it basically took the last couple of seasons and said, I think you're just going to keep on trucking here. So that's actually pretty interesting. And so notice, by the way, that it made the graph on its own. I didn't do that. And you can, what does this do? I don't know what that does. Oh, you can zoom in. That's pretty cool. So it made this graph on its own. And, oops, go back here. Oh, that's weird that it does working again. I just wanted to get back to it because I clicked on the chart. There we go. Now we're back into here. So that's pretty cool. And so what's case 5? Forecast multiple future values. Ah, okay. So let's figure out how to do that. Forecast future values. Columns to forecast. Let's get all of them, please. Oh, okay. So I don't know why you wouldn't just do this right away. So let's see how far into the future they went here. It looks like they went, so it started in 2010, ended in 2012. They're just doing the rest of 2012. And okay, so we'll do forecast. Cool. So it's weird. Like it doesn't seem to have the seasonality into the future. Man, that's... Wait. Oh, it's because it didn't quite get to it. Let me undo. If I hit undo, what happens? Nothing. Let me just come down here and go a little bit further into the future. So I'm just going to delete all of these. Delete. And I'm going to stretch this down and see if it'll get the seasonality a little bit better. All right, so we're going to have it go into the future a little bit further. Because I don't think it actually made it to the next seasonal spike. There we go. Hey, very interesting. So it tries to replicate this shit, and then it tries to get some seasonality. Wow, that is pretty cool. All right, so that's basically what I wanted to show you guys.